So this is our quiz review where we're going to be looking at stuff with complex numbers and the factor theorem and fundamental theorem of algebra. Our first problem asks us to factor x squared plus 36 over the set of polynomials with complex coefficients, which means we can use complex numbers when factoring. Well, we have a, it was the complex conjugates theorem that told us that a plus bi times a minus bi, when we multiply, we get a squared plus b squared. And that's what we're going to use to help us here. So this would be x plus 6i times x minus 6i is how we would factor that. And if you're wondering, well, wait, why does that work? I'm going to show you if I FOIL this, my first terms would be x squared. My outer terms would be minus 6ix, and my inner terms would be plus 6ix, and they cancel, and then minus 36i squared for my last terms. These cancel, and this minus 36i squared, remember I squared is negative 1, so negative 36 times negative 1 is positive 36, so we get x squared plus 36. I'll show you another one. If you were asked to factor, I'm going to do it up here at the top of the page, x squared plus, pick any perfect square you know. It could be 100. That would then be x, oops, I'm starting to write, x plus 10i, x minus 10i, because the outers and inners will cancel, and I'll get minus 100 I squared, which will become plus 100. Let's do another one. X squared plus 25. That would be x plus 5i and x minus 5i. Again, my outers and inners would cancel, and I'd get negative 25i squared, which would eventually become plus 25. Let's go to number 2. Identify the polynomial function with zeros at 4, 6, and negative 3/5. So my factors, remember, when we know the zeros, write the factors. That's what we learned in our factor theorem, was that if you know the zeros, you know the factors. If you know the factors, you know the zeros. So my factors would be x minus 4, x minus 6, and x plus 3/5. Now we can't leave this fraction, so I'm going to have to pull that 5 there. So my factors are still x minus 4 and x minus 6, and this one is going to be 5x plus 3. And now I need to take all of this and I need to multiply. So I'm going to do these first two, and I get x squared minus 6x and minus 4x give me minus 10x, and then negative 4 times negative 6 is positive 24. And I now need to multiply that by 5x plus 3. I start by distributing the 5x to all 3 in the trinomial, and I get 5x cubed minus 50x squared. And let's see, 24 times 5 would be 0 to 120. And that's when I took 5x times each of those, and now I'm going to take 3 times each. And I get 3x squared. I'm going to put that there. 3 times negative 10 is negative, did I forget? Oh, this had an x on it. This was 120x, sorry. Then I get negative 30x. And then 24 times 3, I get 72. And I get 5x cubed minus 47x squared plus 90x plus 72. That's my final answer. This next one, number 3, we're asked to express this in an a plus bi form. But whenever you have a denominator with an I in it, you have to rationalize. So 2 plus 7i divided by 9 minus 7i, excuse me, I'm going to have to multiply by the complex conjugate, 9 plus 7i, but I have to do it in the numerator and the denominator so that I'm really just multiplying by 1, and I'm not actually changing the value. Right? I'm going to need to FOIL. First terms, I get 18. Outers, I get 14i. Inners, I get 63i. And last, I get 49i squared. In my denominator, I get 81. And then I get 9 times 7i is 63i. Negative 7i times 9 is negative 63i. They always cancel. That's what I wanted to have happen. And then minus negative times a positive is a negative. 7 times 7 is 49, and then I squared. Let's keep going. This plus 49i squared is 49 times negative 1. So it becomes minus 49. So 18 minus 49, I get negative 31. Just used my calculator to do that. And then 14 plus 63 gives me 77i. My denominator, these cancel, and this becomes plus 49. And 81 plus 49, I get 130. Let me go ahead and separate this to negative 31 over 130 plus 77i over 130. And I'm going to use my calculator to make sure that my fractions are reduced. Negative 31 divided by 130. Math, enter, enter. That one cannot be reduced. Let's try 77 divided by 130. Math, enter, enter. That one also cannot be reduced. So there is my final answer. Number 4 asks me to solve this quadratic over the set of complex numbers and put all non-real solutions in a plus bi form. So this is telling me to use the quadratic formula. It's telling me it's not going to be able to be factored. It's not going to be able to find the zeros on the graph. You're going to need to use the quadratic formula. So A is 2, because remember this is A, B, and C. So A is 2, B is 3, and C is 5. My quadratic formula is opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times 2 times 5, all divided by 2 times 2. Right, I'm going to start using my calculator now. So I'm going to do what's underneath that radical. 3 squared minus 4 times 2 times 5, and I get negative 31. And I know that 2 times 2 is 4. 31 I recognize as a prime number. There's nothing that 31 can be divided by, so I don't have to simplify the radical, so that's kind of nice. This negative gets pulled out and becomes an I. And I am left with negative 3 plus I square root of 31 over 4, and negative 3 minus I square root of 31 all over 4. I could separate those. These can't be reduced because all three of these numbers would have to be divisible in order to reduce this. But I can write it as negative 3/4 plus I square root of 31 over 4, and this answer would be negative 3/4 minus I square root of 31 all over 4. And that way they're in A plus BI form. It says, given that one zero of this polynomial is 4, find all the other remaining zeros. Well, remember that when we know a zero, we know a factor. So x minus 4 is a factor. So when we know a factor, we can use it to divide. There's no placeholders I need to add in either place, so I can begin dividing. 2x cubed divided by x is 2x squared. I'm going to take this 2x squared and multiply it by both. I get 2x cubed minus 8x squared. And since I'm going to be subtracting, I change my signs. And I get 7x squared, carry down the minus 25x. Focus on the first. 7x squared divided by x is plus 7x. Now I multiply the 7x by both of these, and I get 7x squared minus 28x. Since I'm subtracting, I change my signs, and I get 3x minus 12. Focus on the first. 3x divided by x is 3. Multiply 3 times x, and by negative 4, and that's what I wanted to happen. Whenever it's a factor, it should give you, it will give you a remainder of 0. If it doesn't, then you know you made a mistake. Now what we need to do is use this polynomial here, and we need to, you can see if it can be factored, and if it can't be factored, then we need to use the quadratic formula. Let's see if it can be factored. We don't know, it didn't say that we are going to have complex zeros. So let's check and see if this can be factored. Now, since it has a leading coefficient greater than 1, I'm going to use slide and divide and get x squared plus 7x plus 6. And I need to think about product of 6, sum of 7. My factors of 6 are 1 and 6, 2 and 3. Well, look, 1 and 6 would work. So x plus 1, x plus 6. So this is factorable. I don't need to do quadratic formula. Now that I multiplied by 2, I need to divide by 2. And I get x plus a half and x plus 3. Slide that over, and I get 2x plus 1 and x plus 3. Now, those are my other factors. I'm still looking for all my zeros. So set each one of these equal to 0. And I get 2x equals negative 1 because I subtracted 1. Divide by 2. X equals negative 1/2. There's one of my other zeros. X equals negative